Welcome everyone. In this video I'm going to show you how to build a Peltier cooler based cloud chamber. And in the project I will use this device as a base. So in one of my previous videos I have already tested this thing. As you can see on the back side, on the heatsink side, we have four 8 centimeter wide fans. They are 12 volt operated. And then on the other side we have this, let's call it cold plate. So this is a 20 centimeter by 18 centimeter 4 millimeter thick aluminum plate, and between these pairs of screws, M4 screws or bolts, there is a Peltier cooler. So between each pairs, so there are 4 Peltier coolers cooling this thing, and they are cooled by a TEC 12705 Peltier cooler. It's a 5 ampere unit, and based on the test that I ran, the exposed plate, the center of it, this part here, which I'm pointing at, was able to go down to like 2 degrees Celsius, plus 2 degrees Celsius. I even tried it with an extra good fan with a high RPM, but then I concluded that it's not the fan, not the airflow, which restricts the temperature that I can achieve on this side, but it is more like the combination of the heat sinks and the Peltier coolers. So obviously those Peltier coolers which are inside this unit by default, they are not powerful enough. And then of course you can see that these heat sinks barely have any good and large fins, so they cannot really heat or they cannot really dissipate the heat produced by the Peltier coolers. So then I will only keep the cold plate, and then I will replace this mess here, which mess is the Peltier coolers, of course, and then the heatsink. So regarding the heatsink, this will be the replacement of the heatsink. So this is a regular, let's say, high power CPU cooler. I saw the reviews on AliExpress. I bought it from AliExpress. Link is in the description. And several users were using high performance CPUs with this one, and they were satisfied with it. And this is a relatively cheap stuff, so it's good to use it. But what is more important is on this side, which is still untouched because this thing just arrived on the post. But what we can see here is that this side, if I measure from copper to copper, is 4 centimeter wide, and also from copper to copper it's also 4 centimeters, which happens to be the exact size of a Peltier cooler. So then I can perfectly match the hot side of the Peltier cooler with the copper side. So this will cool the Peltier coolers, and then between each screws or bolts there will be one of these devices mounted. So there will be 4 of these guys. I have the other 4 next to me. 4 of these guys will be on the other side of this. So we have this heatsink, but we need a Peltier cooler, or more precisely we need 4 of those. So then this is another thing that I tested in the past. This is a TEC2 19006 unit, and if you see from the side view, this is twice as thick as a regular Peltier cooler, because this is a stacked or cascaded Peltier cooler. And because of this construction, the cold side of it can reach much lower temperatures. I have another video just right there where I tested this thing, and I was able to go down to minus 35 degrees Celsius with the surface of this thing. So with all the losses and everything, here I expect, let's say, minus 20, minus 25 degrees Celsius with the covered thing, because this will be covered with an enclosure once it's made into a cloud chamber, because as its name suggests, it has to be a chamber. So this will be covered with a transparent box, and then therefore it will be a chamber. But then this will be the main actor in this video, and 3 of its friends. So I will put between each screws this guy everywhere, and then they will be obviously cooled by this CPU cooler, each of these units. And then they will be powered similarly in a similar way as I powered this unit. So two Peltier coolers will be parallel, as I did it with these cables here. And then they will be fed parallel with the same type of power supply. But that I will explain later. So what I will do now is I disassemble this, and then I show you a few things, because I will mount some thermometers here and there, and then I discuss why I do it and how I do it. So let me now disassemble this and do some work, and then I explain you more. So here is the plate. I cleaned the 4 Peltier cooler places, and then still this is the front side with the original foil on it. So then what I want to do is that I want to be able to measure the temperature at different places. So therefore I have to remove some of these insulating foams because I want to measure the cold side temperature, which is basically the temperature of this plate. But I don't want to put anything on this side, because this side will be painted later on to a black color to give a good contrast for the vapor trail. So then I want to keep this undisturbed. But then on this side, you can see we have this thin layer of foam. I can like carve out small places here. I want to put 3 probes on this plate. So I want to carve out 3, let's say, small trenches between these 2 Peltier coolers in the center and between these 2 Peltier coolers. And then I will glue some NTC thermistor probes here. So these are the probes, NTC thermistor probes, 10 kilo ohm. I made them myself, so I just cut these wires, put these connectors on it, and then soldered everything and put the heat shrink tubes there. And I use these NTC thermistors because in some of my previous videos I've already made this thing, which is a 10-channel thermistor based thermometer. Here are the 10 JST plugs. One device is here also, another flat probe. So I have 5 of those, and 3 will be mounted in the corresponding places. So I will try to carve out the foam and glue them on the metal, and then we'll see if it stays or not. So far this is how it looks. So I removed the foam and then I kept it. I used some super glue and glued the probes, and hopefully they will stay there. And then I put back the foam piece that I cut out from the area where the probe is located, and then I just glued it back using some tape. And before you would comment on this, I have some additional foam, and I was thinking that once I make the, let's say, final version, I will add that foam on top of this foam layer, so there will be no, let's say, exposed parts here, here, and here where the cables go out. But I needed to cut these channels, as you can see, there, a little there. That was probably the best. It's quite narrow. This was a bit too wide. So I had to cut these channels so I could get the cables out in a proper way. But yeah, this is the first version. and I'm building this as I record this video. So probably I could improve a lot of things with the next version. So just bear with me. So just to show you, this is the foam. It's a 1 centimeter thick foam, and it's about the same width as this plate. So I can just cut it and then carve it here and there for the holes. And then you can see that it has an adhesive layer. Hopefully you can see it. And I can glue it over this. But first I just want to make sure that I can mount everything. And actually that will be now the next part, is that we have these cleaned places. And then I have 4 Peltier coolers. So first I will apply some thermal grease. I have this guy. I apply it everywhere. And then I put on the Peltier coolers. And you can see that the cables already left their imprint. So I will just use these, let's call them channels, to let the cables go where they have to go. And then I will mount the CPU coolers. So then that will be interesting. But let's first do one by one. So I just mount one Peltier cooler, and then I mount the CPU cooler, and then we will see how the rest can be laid out. So before mounting the CPU cooler, I want to show you this cool thing. Actually, there are a lot of cool things which are very simple but hard to find if you don't know what to look for. So this is a so-called mending plate or brace, which you can find for very cheap on AliExpress. And due to this hole, you can put the screws wherever you want. And that's very good, because then I can put this in between the CPU coolers. And then there you see that I can actually find the 2 holes and perfectly put the screws through the holes and find the holes on the cold plate. And then just to add to this, I will use the default screws, which were provided by the CPU cooler. You can see these. And then I have these guys. So these are just some nylon washers, as you can see there. So I will put them on the bolts. So that will be in between the head of the bolt and these plates, which is good, because there will be a bit less heat transfer by the screws towards the cold plate. So that's nice. And obviously the bolts are too short, but I have some better ones. These are also M4 bolts, but longer, so I will use these. So this is how the mounting looks like. You can see it from a better perspective, hopefully. So the bolts are, let's say, thermally separated from the back side of this plate by these nylon screws. So of course the bolts are exposed, but the metal part which touches this black metal part that touches the bolts, or would touch the bolts, are now separated. And also you can see that this is the hot side, so the hot side is now thermally separated from the bolts, which are then connected to these or this cold plate. And now you can see that this is stable, and yeah, it's really stable. And I had to bolt it very carefully, and if you replicate it, you also have to bolt it very carefully, because you can crack the plates if you have uneven pressure. So be very careful. Just a small turn per side. So turn this screw a little bit, and then turn the other screw a bit, and then go back and forth when you feel more resistance, and then you stop. So another thing is that here you can see the markings, and then this just only shows the direction of the airflow. So then I have to place the next cooler in a way that it will also oppose this, and then I will pull out the air sideways, but the main thing is that the air is being blown inwards from both sides. So then basically just 3 more to go. So I guess I will just speed that footage up, and when the final result is done, I will show you what I managed to do. So now the plate is done, and yeah, it's quite big. Everyone is mounted properly, hopefully. So then I have to figure out the cable management, because now each of these pairs have to be cabled up parallel, and also the coolers have to be cabled up and everything. And then I will flip the whole thing, and we will see how this performs as a cooler. And I made 5 of this probe. So the 2 other probes will go in between the fins of these coolers, somewhere in the middle here, just to see how warm the temperature gets around these heat sinks, or more specifically, this will be inside one of these heat sinks. So it can be almost related to the hot side temperature. Of course, it's not measuring directly on the surface of the Peltier cooler, where you have the junctions of the semiconductor pieces, but it's a good estimation at least. So if it's not getting to 60 degrees and the cooler cools well, that's at least a good sign. So let me wire up these things, and then I will return to you and show you the result. So now I wired up the cooling plate, but before wiring up everything as the final step, I just want to mention a few words about this power supply. So under these 2 DC-DC converters, here we have a, sorry for the upside down, 24 volts and 16.7 amps, so 400 watts of power supply. And then, as you can see, and as you can see on my website on the drawing, the positive rail and the negative rail is split into two rails. And then each of these rails go into their own individual DC-DC converters. And then they will go, each of these DC-DC converter outputs will go to a pair of parallel connected Peltier coolers. So like here we have two Peltier coolers, and then two positives are connected together, and the two negatives are connected together, and then obviously they go to the positive and they go to the negative rail like this. So the thought behind this is that these Peltier coolers will feel themselves good or ideal when the supply current is around 5 amps. And then what I want to do is that with each rail I will regulate the voltage to a certain degree or to a certain voltage that each Peltier cooler or Peltier cooler pair will get 10 if it's the whole pair, or 5 if it's an individual Peltier cooler amperes of current. So once again, if we go back to this pairing, then when they are connected parallel to these DC-DC converters, we have two Peltier coolers each. So in the parallel rail, in total, there will be 10 amps. But since they are connected parallel, each Peltier cooler will get 5 amps. And then this rail will provide roughly 12 volts and 10 amps, and this rail also will provide roughly 12 volts or 14 volts and 10 amps. And I did some calculations which is more detailed on my website, so please check it. But I assumed that the 400 watts power supply has an 80% efficiency together with the DC-DC converters. So therefore the maximum output which I can get on these rails, which directly go to the Peltier coolers, will be around 320 watts. And then that is split into two, so 160 and 160 watts. And as I mentioned previously, we need 10 amps and roughly, let's say, 14 volts, so that is 140 watts. So we still have a little bit of wiggle room in terms of output performance or electrical power. So that is really nice, so we can be sure that the power supply will be able to supply everything. And then I have these two guys, which I also built in my previous video, check there in the corner. And I actually will release a video about their upgrade, because these had a little bit of mistake, not crucial, but I ordered some new PCBs, and then I will make them into a new unit, and they will also have different displays, because I implemented software for 3 different displays. This one, 0.96 inches of diagonal, and I have another OLED display which is 1.3 inches, and then I have a big graphical LCD which basically has the same area as the wall PCB. But why I have these is because these are power meters. So I will put these here, more precisely something like this, just as a demonstration. And then I will connect the Peltier coolers here. So this power meter will be in series with my circuit. Therefore, I will be able to measure and monitor the current and the voltage going towards the Peltier coolers. So I wanted to add this to my Peltier cooler circuit, because it's easy to monitor everything. And then I can use these two potentiometers, or more precisely just one, because I, let's say, unlocked the CC totally. So the current control is basically, it is what it is. It doesn't matter, because I limit the current with the voltage limit, which is the CV potentiometer. So then, now I will just wire up the rest. So I will make sure that the power meters are in the circuit properly, and then we will do a test. And if the connection is still not clear or something extra is needed, please visit my website, because I carefully wrote a big article about the whole project, including how I wired everything and what are the numbers behind the wiring. So let me do this work, and then we check how this Peltier cooler based cooling plate works. So I arranged everything, as you can see, but I could not fit everything on the picture, so I will just take some photos and upload it to my website just to show you what is what. But here we have the power supply, and then one rail comes here, which will be a self-sufficient DC power meter, and then this will feed these two Peltier coolers. And then another wire goes somewhere behind, and that will feed these two Peltier coolers. Then we have thermometers on the back side of this cold plate here, in the center here. And then I also put some thermometers inside this area where we can expect higher temperatures. So it's just in between the heat sinks. And then I glued with a Kapton tape a piece of thermocouple. You can see now I'm touching it, so it is getting warmer and warmer. But that is just for control. And then here, it's not really visible, but at the bottom of the picture, I connected all the 8 fans, which are blowing the air inside. So the excess air will come at the sides, and later on it will come with the forced air, because I will put some fans on this side and the top side, which will like pull out the air which is pushed in to avoid the hot air being stuck in this area. And then I have the thermometer, which you can see barely here, so I can monitor this. I will take a picture of these whole things, and for some reason I can see that the first thermometer measures roughly 2 degrees lower than the rest of the thermometers, so there should be some issues with the wiring or something. I don't know, but let it run as it is. So then once again I will just check all the circuits, if there is any short circuit or something, or if any of the wires are hanging inside the fans, and then I start up the circuit. So everything seems to be good. So first I just start the fans. I have a power supply separately for them at this moment, so I will just start it. And now the cooling is going. So now I will start this power supply. I have a outlet which has a switch on it, so I will just switch that outlet on, which will turn on this power supply. But the DC-DC converters have their own individual switches, which I might be able to show. And they are of course switched off. So then I will have to switch it on as well. And I have a screwdriver if I need to adjust the voltage going to the Peltier coolers. Probably you can see the LED here, green LED. So the power is on, but the power is not on for the DC-DC converters. And I just take some pictures before I start recording, so that will be the reference picture for the temperatures. So this power meter is on, and the other one is also on. But something fishy is going on with the other side. So this side is getting cold, but this side is not getting cold, so I have to check that. So for now I switch off the power supply. So apparently the other power meter, which is somewhere there, had loose contacts, so this side of the plate did not get enough power. So attempt number 2 is going now. So I just turn on the power supply, and now it seems to work. So actually each rails take up 135 watts roughly. So this side, the left side of the plate, is running at 12.7 volts and 10.4 amps. That's ideal because it's a little bit more than 5 amps. And this is also. So now the temperature drops. So all we need to do is I wait for like 5-10 minutes until the temperature starts to consolidate, and when everything is fine, then I do some evaluation. So let's wait for like 10 minutes ish. So now roughly 10 minutes passed, and you can see that we reached significantly lower temperatures on the cold side. Actually, you can see the ice forming, but we have like -9 degrees Celsius almost, with an exposed cold side. And that is 9 degrees lower already, as compared to the value that I could reach with my other heatsink. So these heatsinks definitely do the job correctly. So that's nice. And now I will put a lid on this just to see how low I can go, because I still need to go down like 10 to 15 more degrees. So I want to go below -20 degrees on the cold side, and for that I need more cooling. But also, if I read the thermistor values, which are located here, here, and here on the other side of the plate, they also show -9, -8, and -7 degrees. So it's getting colder and colder, so it's comparable with this. And I can see that this is not necessarily touching the metal properly, because you can see that the temperature decreases if it is able to touch the metal. But of course, the glue doesn't hold very well in low temperature conditions, so it released the probe a little bit. So then I created this frame, which is a 3D printed frame, and it fits this device exactly, because the box that I want to put over this is exactly 20 by 20 centimeters, but this is 18 by 20 or something like that. So I need this converter. I just have to figure it out how to mount it. I have to mount it like this. And this is good because it also adds some extra insulation, at least from the side. And then I have this nice box, which fits here very neatly. So now we have a nice refrigerator, a transparent one. So I just wait for another 10 minutes and see what the temperature will be. So nearly another 10 minutes passed, and the temperature is still decreasing, but slower and slower. But we can see that now the cold side temperature is -17.7 degrees. Maybe by the time I finish talking, it will reach -18 degrees. So it goes quite well. But I can see that now it's starting to struggle with the temperature. So of course the solution for this would be to improve the insulation at the bottom. So now basically the only thing, or only few things that we can do, now it reached -18. One is to lift this a little bit up to have better airflow. Then add the fans sideways. So there are not only fans this side and this side, but also this side and that side. That could help a little. And then I could also finish the insulation at the bottom. As I said, I have this foam. In fact, I have a thicker one, which I could use to patch up the bottom perfectly. And then I could probably improve the cooling, because now we just need 2-3 degrees. And probably I would be able to create the supersaturated alcohol vapor for the cloud chamber. In fact, I could try it already now. I will just dampen a few of these bits with isopropyl alcohol, throw it in there and wait for 10 other minutes, and we will see if we can see any streaks. But it will be hard to detect because now the surface is covered with that blue foil, which is obviously not giving a good contrast with these lighting conditions. But just to test, it should be sufficient. So I will put these two things in, or maybe even more, because I have a jar of them, and see if the evaporating alcohol will reveal ionizing particles. So nothing seems to happen, and I think I know why. The temperature is almost good, so that should not be the problem, but of course I did a mistake by putting the soaked clothes in just now. which means that the evaporation cannot really happen very easily because the temperature is simply too cold in this chamber. So then I will shut this whole thing down. I improve the insulation, fix the chamber properly, probably will cover everything with something black on the cold side, and restart everything from room temperature. And then I just jump back to this part of the video after everything is cooled down, and then hopefully I can come back with some good news. So let's see what happens in like 10 minutes. So eventually I repainted the surface, so now it's black. You can see that at the edges it's not yet perfect, but I will add another layer later. But the paint is now dry, and it gives a dark background, which should be sufficient. And then I also added some foam on top of the already existing thin layer of foam. I took some pictures during the process, so just visit my website to see the behind-the-scenes photos. And then I have this felt. Now it's just in a disc shape, but what I did is the following. Here is another CPU cooler, identical than these four under this plate. And you can see that we have the hot side part here. And on top of that, of course, I had this plate to clamp it down here against the other side of the aluminum plate where you see the corresponding bolts. So I put a felt disc, or not a disc, but a rectangular shaped felt pad there, and then I clamped it down. And that is to further decrease the chance of heat getting to the screws and then to the cold side. So that is something extra that I did. So you can see it probably from this perspective, that now each of these four CPU coolers are clamped in a way that this mending plate has a felt pad underneath, and then it is pushing against the backside of the actual mounting surface. And finally, as I mentioned, I was going to use this kind of insulating foam. And while I was talking about this foam, I said that I even have a thicker one, which is this guy here. You can see the difference. It's twice as thick. So actually, this foam is glued against the wall backside of this plate. So it's adding extra insulation. It is everywhere, so it's completely covering the wall backside, except where I mount the Peltier coolers. So now the next thing is that I will use some felt pieces, like this kind of pad, or I will just cut some strips and then soak them in isopropyl alcohol and then put them in this enclosure. I will rearrange the camera a little bit so you will see more, hopefully. And then I will also hope that the isopropyl alcohol doesn't dissolve my paint, because obviously I haven't checked what kind of paint I was using. It's just a matte black color, but that's all I know about it. So we just hope that the paint doesn't start to get dissolved. And then also now we are at room temperature, as you can see. And that is a very important detail, because just a few minutes ago when I tried to just throw in the soaked felt pads inside the already cooled down chamber, then that was a bad idea, because I obviously could not expect too much evaporation at such low temperatures. So let me prepare everything and then we take a look at the things, how it works. So I checked all the cables. Thermometers are inserted everywhere. We still have one of the units having like a 2 degrees offset or 3 degrees offset, but we don't care about that right now. So the first 3 thermometers will show the different positions. Bottom side and top side is by 1 and 2, and then the middle is number 3, and then 4 and 5 is the heat sinks, and then the last one is sitting here, so it's basically room temperature roughly, and then this is a K-type thermocouple attached there. Hopefully when I remove the tape it will not strip off the paint, but let's worry about that later. So now everything is arranged nicely, so I just need to power up the things. And then later on, when the temperature drops to a better temperature level, then I will change the camera view. But here you can see that I soaked a long piece of felt with isopropyl alcohol, and we are at room temperature, so it's already evaporating there and filling up the chamber with the vapor. And then that's what we have there. So hopefully that will be sufficient. So let's start the power supply. So both power supplies started properly, and I can see on both power meters that we are at roughly 13 volts and 11 amps. So we are now consuming 140 watts per rail, and you can see that the temperature started to drop. So now I let this settle a little bit, because we are now have to go down 20 degrees below the current temperature. So let the cooler does its work, and I will come back to you when I start to see better temperatures. So I'm back, and I figured out most of the things, I think. So the crucial thing here is not actually just the temperature, but it's actually the amount of alcohol that you put on the felt inside the chamber. So now actually the felt runs all around the chamber, and I figured out a way to fix it. So I have like a 2 centimeter wide felt strip, something like this, and then the entire length is just fixed by magnets. So I have magnet inside and another outside, and then since they attract each other, I can just pinch them against the wall of this enclosure, and they stay like this, as you can see. And then in addition to soaking them a lot with isopropyl alcohol, I have this spray bottle, this thingy, which is just a cleaning solvent, but then it is actually, if it could focus, it's 99.7 isopropyl alcohol, so it's quite pure. But then we have this cup here. It's a stainless steel cup, and that also has isopropyl alcohol. I bought it from the pharmacy, so it works. And yeah, it's really the key thing here is a bunch of alcohol, because now you see the thermocouple there, the green wire, that is at minus 25.6 degrees Celsius, so it's cold enough. But yeah, in the beginning it was not producing any kind of visible streaks, so that's a big problem. But then you still cannot see anything because of the reflections, because I have external lights, so that has to be fixed. But one more thing that is kind of crucial is the sealing. Now I don't have a good sealing around the edges of the chamber, but I will fix that in the next part of the video, because this is getting very long. But yeah, that is also a thing. And another thing that you have to solve is that it's not only that you put in the rag, which is soaked with alcohol, but you have to make sure that that alcohol will be able to evaporate. So either somehow you heat them, or time to time you touch it, or something like this, to make it a bit warmer, and then it can release more vapor. So now I will shut down the external light sources, and we will only rely on some smaller light sources, and I hope that the camera doesn't go crazy. So now one light source is off, and then I turn off the light in the room. And now probably nothing is visible on the camera, but let me do something. This is just a lamp from my bike. And once I manage to find the angle, and once the camera is willing to focus, then we have a lot of action going on. You can probably guess that I was kind of cheating in a way that there is a particle, which is a mineral, which I forget how it's called, but I will put it on the display. So I have that mineral there, and it's emitting some radioactive particles, and you can see that it works nicely. So unfortunately the plastic enclosure is a bit dirty, as you can see, but nevertheless you can see that around this particle we can see a lot of traces which are created by ionizing particles. So as I said, the difficulties, one is to make the alcohol evaporate well enough, and then the other is to seal this chamber well enough again. And the third one, which I'm still struggling with, and you can see it on the video from the flickering, is the lighting. So now I have a small edge on at the edge of the chamber, so I cannot have the light on the plane of the surface basically, but I can only get the light in at an angle, so I cannot make it perfectly parallel with the surface, and that's a problem because I want to do that in order to highlight the traces better. So I will have to reconsider how I mount this chamber on the cold plate, but it will work in the next iteration. So I think I will make another video where I fix all these things which I discovered now, and then that will also allow me to have another longer video and discuss other things, because I have several of these minerals which are here in the chamber, and then I can introduce all of them. I think I have 5 or 6, and we can see how they look like in the chamber, and what kind of traces we can see, or what kind of trajectories we can see. So yeah, the concept works at least, and that was my main goal with this video, is to show that you can actually rebuild this cold plate, and instead of using the original heat sinks and the original Peltier coolers, we can use better ones. So we can use a CPU cooler to cool the hot side of the Peltier coolers, and then we can use TEC2 1906 Peltier coolers. These are cascaded or stacked Peltier coolers, so they can reach very cold temperatures. In fact, this is now the temperature on the cold side. Basically at the bottom of the picture here we have the thermocouple there, right here, and that is now, yeah, this much, or this little, -26. Actually, if I don't bother this thing, I could go down to -28 degrees Celsius, so it can be even better. So that's nice. And yeah, this thing works. It has to be just fixed here and there, but that will be in the next video. So I hope that this video was useful to you, and I hope that you found it interesting as well. And if you want, you can build your own cloud chamber as well, because I documented everything. So please visit my website. Link is in the description, and you can see all the things, what parts I used, what are the dimensions, what are the measurement values, and so on and so on. So you can recreate this project relatively easily. So please stay tuned for the part 2, because there I will show you more interesting and spectacular stuff, hopefully. And until that, see you in the next video.